Okay, 5 more questions to go. Paper 2, calculator allowed. So this is an OCW question where you are going to be awarded marks for how you communicate and how you set out your workings. So the perimeter of a square is 76.4 meters. Calculate the length of its diagonal. You must show all your working. Okay, so a little diagram will help you. I know it's a square, so all the sides are the same length. And I want to work out what the length of its diagonal is going to be. So I want to work out that distance. Because it's a square, I know that each side is the same. So 4 lots of the same side equals 76.4. So square has equal sides. It's 4 equal sides. So if each of those were x, then the perimeter is going to be x plus x plus x. Perimeter equals x plus x plus x plus x. So 4x equals 76.4. So I would divide both sides by 4. .1 centimeters. So each of those sides is 19.1. I know that the square has got right angled corners. So what I've got now is a right angle triangle where I know the 2 sides and I want to work out the diagonal, and to do that I'm going to use Pythagoras. And I know that I'm trying to find the longest side, and with using Pythag I have to square all the sides. So d squared would be 19.1 squared plus 19.1 squared. So if I square 19.1 squared plus 19.1 squared equals 729.62. So, excuse me. So the square of the diagonal is 729.62. To get the diagonal, I have to do the opposite of squaring, which is square rooting. So square root of 729.62 equals 27.0114, and so on. It doesn't ask you to round it to any particular accuracy, but because they're giving us a measurement to 1 decimal place, it would make sense to round this to 1 decimal place, which would be 27.0, because the next digit is smaller than 5. So we write equals 27.0 to 1 decimal place. So 4 marks for the maths, 2 marks for the way that I've set it out. So diagrams help. I've said the square has 4 equal sides. I've then formed an equation. If you just wanted to say, well, it's going to clearly be 76.4 divided by 4, that's fine. And then I'm saying, to work out that diagonal, I'm going to use Pythag, where I have to square the sides. I'm trying to find the longer side, so I have to add them together, and then I have to square root them afterwards. Question 7. A rectangle measures 38 centimeters by 26 centimeters. Each measurement is correct to the nearest centimeter. Calculate the least possible area of the rectangle. So I've got a rectangle. I know that that is 38, and I know that that is 26. And to work out the area, I know I'd multiply those together. But I want a higher tier exam paper where calculating the area of a rectangle in its own right simply wouldn't be asked. So that's too straightforward. So if I look again at the question, I can see that this is one where it's been measured to a rounded value. And I want to find the minimum possible. So it's been rounded to the nearest centimetre, which means that 26 could be anything up to 26.5 or anything as small as 25.5. And my 38 could be anything as big as 38.5, 0.9, or as low as 37.5. So with these questions, you work out what the maximum and minimum possible measurement will be, and then you look to see what you want to find. So for the smallest possible area, I want to multiply the two smaller sides together. So it would be 37.5 times 25.5. If it had wanted the greatest possible area, I'd have multiplied the two maximum values together. So 37.5 multiplied by 25.5 is 956.25, and for area it would be centimetres squared. So you've got to watch out for that, spotting that rounding question. Question 9. Draw the enlargement of the given triangle using a scale factor of -2, so this is grade A, negative scale factor, and -2, 1 as the centre of enlargement. So -2 is the x coordinate, 1 is the y, so -2, 1 is there. That's our centre of enlargement. And when we are doing a negative enlargement, we multiply by the size, the magnitude of the factor, and we have to reverse our movements. So if I'm interested in that point here, to go from the centre to there, I'm going right 1, 2, 3, down 2. So right 3, down 2 is going to become left 6, 1, 2, 3, 4, 5, 6, up 4, 1, 2, 3, 4. So I'm doubling 3 and 2 to become 6 and 4, and reversing the direction. So right 3 becomes left 6, down 2 becomes up 4. So if I then do this one here, I'm going right 1, 2, 3, down 1, 2, 3, 4, 5. So it's going to be left 6, up 10. Left, so back to the start, left 6, up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that one ends up there. And then finally, that one is going to be right 1, 2, 3, 4, 5, down 1, 2, 3, 4. So right 5, down 4 becomes left 10, up 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up 8. 1, 2, 3, 4, 6, 7, 8. So you can see that the enlargement, that triangle is twice as big as that one, but this has been reflected to the opposite side of the centre of enlargement. So that's a grade A. Question 9. So we've got some algebra here. Now this one, if you look at what we've got here, show that that left-hand side is, and that's an equal sign with 3 bars in it. That means is equivalent to. So we met the equal sign, we know all about that. We've met inequality signs. With an equivalence, all we have to do is to simplify that left-hand side to show that when we simplify it, we get that. So we're going to work with 10w plus 3 minus, now here I've got 2 minus 3w squared. When you're squaring something, you're multiplying by itself. So that left hand side, all I've done is written down what they've given me, and then here I've got this square, which means I multiply it by itself. So now we're going to use FOIL because we've got a double pair of brackets. So working with this one, first of all, I've got 10w times w is 10w squared, so that's first. Outside is 10w times minus 1, which will be minus 10w. Then I've got my inside, which will be plus 3w. And then I've got my last, which will be minus 3. Then I'm on to my second set of brackets, and where most students will get this wrong is because of that minus sign there. Because that's a minus, I'm going to expand this out using FOIL, but I'm going to keep it in one bracket just because I've got that minus 1 there, so I don't forget about that minus. If it was just a plus, it wouldn't be a problem. So first, 2 times 2 is 4. Outside, 2 times minus 3w will be minus 6w. Inside will be minus 6w. And last will be plus 9w squared. So I got 10w squared. I can tidy up here. I got minus 10 and I'm adding 3. We've finished multiplying. We're just moving up and down a number line now. So at minus 10 adding 3 will take me to minus 7w minus 3. Now I'm going to get rid of this bracket by multiplying everything by minus 1. So I get minus 1 times 4 is minus 4 plus 6w plus 6w, because I've got minus times a minus, minus times a minus, and then minus 9w squared. Right, now we're going to tidy up on we're looking to end up with something like the right hand side there. So I've got a 10w squared minus 9w squared is 1w squared. So I've dealt with that, I've dealt with that. I got a minus 7w plus 6w, which take me to minus 1w, plus 6w, so from minus 1 add 6 will take me to plus 5w. Now I'm looking up here and I'm feeling good because I got the w squared, I got the 5w, so I've used that and that and that, and then I got minus 3 taking away another 4. It's not minus times a minus is a plus because I'm not multiplying. I'm only multiplying when I'm clearing out brackets. So minus 3 on your number line, go down another 4 places, and I get to minus 7. So I'm showing that that right hand side, that left hand side, sorry, by getting rid of all the brackets and simplifying the algebra equals the right hand side. Job done. Use the quadratic formula to solve the equation w squared plus 5w minus 7 equals 0. Give your answers correct to 2 decimal places. So you practiced this last week. Quadratic formula is this one here, x equals minus b plus or minus and so on, and we want the formula in the form ax squared plus bx plus c equals 0, which it already is. The only difference is it's w, not x, so we don't have to worry about that. So a is going to be 1 because there's no number in front of the w. So a will be plus 1, b will be plus 5, and c will be negative 7. And instead of having x equals, I'm going to have w equals minus b, so that'll be minus 5 plus or minus the square root of b squared 5 squared minus 4 times a times c all over 2a. Then we start tidying up. W equals negative times a positive, signs are different, answer's negative. Plus or minus 5 squared, 25. 4 times 7 is 28, times 1 is 28, minus times a minus is a plus. 2 times 1 is 2. W equals minus 5 plus or minus 25 plus 28 equals 53 all over 2. I can't simplify that any further now, so this is where I have to break open that plus or minus by saying either w equals minus 5 plus the square root of 53 all over 2. So on your calculator, exactly as we have written it, we will type it. Fraction button. Minus 5, remember that's the minus, the negative button, that's a subtract button. So minus 5 plus square root 53 all over 2. So you can see there that I haven't put plus in there, I put minus. So minus 5 plus the square root of 53 over 2 equals 1.14. They want the answer to 2 decimal places. It pretty much answers itself to 2 decimal places. So either that's our answer, or w equals minus 5, take away 53, square root of 53, all over 2. We don't have to type it all back in, we can just go in and change that plus to a minus. Now we get minus 6.14. Job done. 3 marks. And then the final question for us is a bit of right-angled trig. Diagram below shows 2 right-angled triangles, ABC and APQ. AB is 8.2, so from there to there is 8.2 centimeters. BC is 6.4 and PQ is 7.9. The first thing they want us to do is calculate the size of angle X. So when they give you a question where they mix up right angle triangles like this, it's often helpful just to work with the triangle that we need to work with to work out that angle X. So if we just separate out what we need. This is triangle ABC. I know that that is 6.4. I know that that is 8.2, and they want me to find the size of that angle. So right angle trig, you need to name your sides. Opposite is opposite the angle, in this case, that you want to find. Hypotenuse would be what's pointed at by the right angle, so we don't know anything about that. And the adjacent is the other one that we know. So in order to find an angle, I need to find the trig ratio relationship, which has got opposite and adj. And what you need to learn are these three little triangles, and you now need to identify which one of those relationships includes opposite and adjacent, because we need to use both of those. So the opposite and adjacent is this one. It's the only one we can use. So tan of x equals opposite on top of adjacent. So tan of x will be opposite 6.4 over adjacent 8.2. In order to get the x, I've got to undo the tan. Undoing the tan means we've got to use the button that's above it, the tan minus 1. So to get x on its own, I've got to do tan minus 1, 6.4 over 8.2. And we put that into our calculator exactly as I've written it. So shift tan gives me the tan minus 1, fraction button, 6.4 on the top, 8.2 on the bottom, move your cursor, close the bracket. So the angle is 37.97 degrees. Now, because everything's given to one decimal place, we can round that to one decimal place, and to one decimal place, 7 is bigger than 5, that rounds up to 10, making that 38 degrees. So that's part A. Part B, calculate the length AQ. So AQ now is in this triangle here. So I'm interested in this triangle, APQ. I know that that is 7.9, and they want me to work out that. Now, in order to do that, I need to know one of these other angles. I don't know anything about this angle, but I do know that this is 90 degrees, and x I've just worked out to be 38 degrees. So this angle here is going to be 90 minus 38. It's 90 degrees from there to there. I know that that's 38. 90 minus 38 is 52 degrees. So I do know that angle. Okay, so same again. I'm going to name my sides. This time, the hypotenuse is what I need to find out. The 7.9 is the opposite, and the other one is the adjacent. So I need to find the trig ratio, which includes hypotenuse, because I'm trying to find it, and opposite, because I know it. So opposite and hypotenuse is sine. And when you cover up what you're trying to find, which is the hypotenuse is the opposite on top of sine, and sine would be linked with the angle. So hypotenuse equals opposite over sine 52. So AQ is what we're trying to work out, which is the hypotenuse. The opposite is 7.9 over sine 52. And that's going in our calculator exactly as I've written it. Fraction button, 7.9 on the top of the fraction, and sine 52 close bracket on the bottom of the fraction. Press equals, and that gives us 10, and again working to one decimal place, that would be 10.0 centimeters. 1 dp. That's grade B. Okay, right angle trigonometry is grade B. So hopefully there's lots in there that you got right. What you need to do with the ones that you got wrong is go back to your revision notes. If it's trig, we practiced it back in September, October. Similarly with this, it was numeracy work we practiced, but there's lots of stuff in there on indices that we've done more recently, and so on. Hopefully there's not too much work that you need to do though. Okay, I will see you in a couple of weeks.